In this video we're going to be going over how to add polynomials using algebra tiles. Now this is a really great method to use if you're a visual learner. It's a really helpful way to learn how to simplify polynomials when they're being added. So let's go ahead and take a look at a couple of examples and see how this is done. Now actually before we get into the examples, let's go over some important drawings to understand. In grade 9 there are 6 types of terms that we need to understand how to combine. There are positive x squared terms, and there are positive x terms, and positive constants, or just numbers. So we'll call them ones. And then the other 3 are the negative versions of those. So we would have negative x squareds, negative x's, and negative ones to be our numbers, or constants. Alright, so basically the ones and negative ones are represented with small squares, like that. And then the negative one would be a different colored square. Now when you're using algebra tiles and drawing this yourself, you can decide which colors you'd like to use, or if you'd rather not use colors, you can use a pencil, and maybe if you shade in a square, it would be positive, and if you leave it not shaded in, it could be negative. So whatever works for you to help distinguish the difference between what's positive and negative. As long as the shapes are accurate. So the numbers are represented by the small squares. X's are represented by a long, thin line, like this, and then our negative x would be the other colored version of that. And then finally, x squared, we use a large square to represent. The reason we actually do that is because x squared, as you know, is x times x, and which is the area of a square. So for example, if x, for example, was 3, meaning that this line was, say, 3 centimeters long, then x squared would be 3 times 3, which is 9, which would be the area of this square. So that's why we use this large square for x squared. X would represent just the length of that side of the square. Okay, let me just erase this. Okay, what the heck? My eraser's not working. Okay, never mind. Well, now that we have an understanding of what we visually use to represent these, let's get started with an example. Let's go down here. Okay. Here's a nice long polynomial that we need to simplify by combining our like terms. So let's go ahead and start drawing out each term. So our first term here is positive 2x squared. And I know it's positive because there's no negative symbol in front of it. We're going to draw that by drawing 2x squared drawings. And from the legend above, we decided that x squared would be my big green squares. So I'm going to draw 2 of those guys. Next, our next term is minus 6, or negative 6. So we're going to draw 6 negative ones. There's 1, 2, 3, 4, 5, and 6. So that represents negative 6. Next up, we've got a plus 3x, so it's positive. And we're going to be drawing 3 positive x's. And we decided those would be our thin green lines. So we've got 3 of those guys. Next up is negative x squared. Remember, if there's no coefficient there, it's just assumed to be 1. So there's 1 negative x squared. And we knew we were going to draw that with a large red square. After that, we've got a plus 2, and we're going to draw that with two positive ones, our little squares. So we've got 2 of those. And finally, a minus 4x, which means it's going to be negative, so we're going to be using red. And we're going to draw 4 red x's, which are the thin lines. 3 and 4. Great. Now comes the fun part. All we need to do is look at our drawings and cancel out things that are opposites of each other. We know we have a negative x squared over here, and we also have a positive x squared over here. Since they're opposite, they're going to cancel out, because if we're adding two things that are opposite, like a 5 plus negative 5, we always get 0. That's why this works well, that we can just cancel these out. And I'm going to do that just with my white marker here. So that's gone and that's gone. We can't cancel out this other x squared because there's no negative version of it, so it stays. Now let's look at our ones here. We've got 6 red and 2 green. So if we're canceling out opposites, we can take out the 2 greens if we also take out 2 of the reds. Now that's done. Now looking at our x terms, we've got 3 greens and 4 reds. So I can cancel out 3 of these greens if I take out 3 of the reds. 1, 2, 3. 1, 2, 3. Now all we need to do is look at what's left and turn it back into this format that we're used to. So, starting with our x squareds, we have just one left, and that is a positive x squared. Next, we'll take a look at our x terms. So there's no x's left here. Over here, we've got 1 left. And it is 1 negative x, which means we're going to be, since it's negative, we're going to be subtracting 1x. I mean, you could write a 1 there, but it's not really necessary. And there we go. Last but not least, we've got our constants to look after. All that's left is these 4 red ones here. And since there's 4 of them, it's going to be a 4, and we are going to be subtracting them because we know that red means negative. So this would be our simplified expression. Now, if that seemed super time-consuming, that's probably just because the first time I showed it to you that it took a little while. But with time, it's actually quite fast and effective method. Now, it's not for everyone, but it is important that you learn how to use this in case it is valuable to you. And plus, on the grade 9 PATs, you are expected to understand how to use these tiles. Yeah, so hope with that one example, that's enough to get you to understand how this works. Yeah, good luck.